The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Kilauea volcano update today, Thursday, February 24th, 2022. We're going to try to keep it briefer than usual today. We know that there are other events happening in the world that deserve attention, so we'll get right to it here on Kilauea. We'll cover Mauna Loa very, very briefly just to mention that it's still very quiet there. If you want to drop any questions in the chat, Dane will get to them as soon as he can. We'll discuss some along the way as appropriate, and some at the end here as well, as we usually do. And we'll start off looking right at what's been happening on Kilauea for the last week. So this is a time-lapse from the F1 thermal camera, courtesy of the USGS Hawaiian Volcano Observatory. And it's showing this process of the lava bursting forth following a pause at the summit of Kilauea. This active lava lake area that's right in here seems to be the main outlet for that surge of lava, and of course it spills out from the smaller pond right here, and it's going usually to the northwest here, but more recently in this past week it's gone off to the south here as well and filled in much of this area off the screen here to the right. And of course beyond that you can see that there's been ooze-ups on this far side of the crater. Ooze-ups and little flows in this far eastern portion. And maybe if I zoom it in, you can perhaps see that there are times where it appears that you have small, unless this was the last week east of the island here, but there are times where you have these small spattering events as well, putting on little lava flows, as we saw last week. Spattering events visible from the northern part of the Kilauea caldera overlook, as well as these other ooze-out flows here in this lowest, most recently covered down-drop caldera block chunk. Let's move back out. More ooze-ups over here on this north side as well. But that's the same pattern as we've seen in the last few weeks and really the last couple months. So won't spend a whole lot of time there. And really the main differences in this last week in particular have to do mostly around the west vent itself, which has become this complex consisting of the cone over here on the right side. This is the south side of the image here. And you see little bursts of spatter that land and build up this edifice, this growing hill of chunks of partly cooled lava. You also have this pond over here to the north of it, which I've been calling the West Pond. There's a little spillway through which the West Pond seems to essentially feed up the lava and overflow it into this large active lake area right over here that looks like a canyon when it drains. Upper part of the image here. So there have been a few changes as far as the construction of the vents over here. We've seen lava burst out of this south side over here and flow more in this direction as well, as I mentioned. We've also seen little changes right around here, right around this West Pond vent, as far as having a little bridge now that disconnects this pond, and the lava flows through a little tunnel to get over to this other area. And it's not quite long enough to call it a lava tube or anything like that at this point, but we'll see the evolution of that as our time lapse of the week. There's that southern burst out you can see there and covering a lot of southern area to the point where it actually curls back around and it dumps back into this main active lake area that's slightly lower by flowing around this whole plateau area. So those are the main events that we're seeing here. I can zoom it back out and take it all in at once again. See some ooze-ups over here on the south side, ooze-ups in the northeast, northwest, and these active changes over here by the west vent. So one last thing I wanted to do with this video is artificially speed it up and keep your eye on this darker area right in here, right in the middle of the image here. But if I really speed it up really fast, back, forth, and back, and forward, and back, you can maybe see that there's some bulging happening right in there. Or if I pause it on these most recent frames right in here, it almost seems like you see some cracking going on. Something like that going on all through this zone, all through here. So like the lava is pushing on that crust from below, and the crust isn't rising like it was before. So it's filling from below and it's bulging that point upwards. And the whole thing is deforming, right? And so this is a 1 week snapshot. Perhaps we'll bring you a longer time lapse to come here, showing this process longer term. But that's one last point to point out, this bulging effect here. And you can really see it most dominantly here in the middle, but it really extends all the way back to over here, right? Almost as if that original plug from the last eruption, that's the core of this hardened lake. It's really the piston rising together, and everything else on the outside is hardening against the crater wall. Not as buoyant as that middle part. It's an interesting buoyancy question that's been going on with the USGS. So one possible scientific nerd quirk to throw in there might be a slightly different buoyancy of the lava that's of that original cap than what we're seeing on the edges here now, and it's causing this deferring effect. This one part of the crater to stay stuck to the wall, and the other part to try to bulge upwards and float above the lava. Of course, also thicker in the middle, right? So there's that effect as well. So some possibilities there. As far as what's happening currently, right now at this instant, I'll reload this right now, and you see some heat here, but there is no lava in this active part of the crater right now. There is a lava pond within this west pond right here, but it might be deep down enough that it's hard to see from certain angles. There does appear to be some active lava on the surface there, and possibly some spattering going on, or some small ooze flows happening from these complex of cones now. That's this west vent area right over here. Occasionally you see some overturns of this lava skin that's left behind within this pit. You can see a little break out from the wall. There sometimes chunks of the wall fall in, and you see bits of lava ooze out from that as well. That's what's happening currently, but interesting to note that even though we are in the middle of what's a near pause here, there still is lava on the surface, but it's oozing out of that eastern side. It's oozing out from that area that was putting out that spatter earlier and feeding the ooze-out flows, which largely have ended over here in this northeast area. See some spot areas of extra heat here and here where maybe you see some small breakouts. It's not like it was before where this whole area was active at the same time. But you see that there's some other process slightly disconnected that's happening under this eastern portion from what's happening over in the western portion. Maybe as that pressure wave migrates from west to east, it's able to be buffered, and it's buffering the deflation inflation events, and pressure is more constant over here, or something like that at a lower level. That's one possibility. So ooze-out flows here on the south as well. Right, that's how it looks currently, and viewed from the regular visible camera. Let's look at this S1 camera here from the south. We see the shadow of the sunset starting to cast across here. But here's my canyon, as I've been calling it. West Vent Complex over here, the pond over here. Everything is dark, so still no lava has returned. Although this pause is expected to end pretty soon, and I'll show you why. This is what we suspect here. A comment here by Richard Williams. Since that cap is angled down away from the main vent, I wonder if it could break up and slide away from the main vent. Thanks for your comment, Richard. Yeah, it's really interesting to think about. That original layer, maybe at the very, very bottom of that original cap, might be the most buoyant part that we've seen floating from the very, very beginning of the eruption back in 2020. And it's been covered with layer and layer and layer of other stuff, right? And so as that composition has evolved, perhaps, and the frothiness of what gets stuck on there has changed. You may at some point weigh it down enough that maybe it can't bob out, or maybe it can actually slide or tilt, and it'll be fascinating to see. Right? Comparing that thickness to the growing depth underneath it of lava that's growing that pit. Right, that's the easy thing to forget, is that even though it looks like it's inactive all at the surface and just small little patches, there's a giant pool of lava underneath this cooled crust on top here. Right,
so on the scale of that, you'd be talking about something that we can see from the cameras, or to the scale in which like the entire lake splits in half type of thing, or what do you envision?
What I think we're seeing now is essentially that effect. I mean, not that the lake is splitting in half, but you're going to see the possibility of cracking anywhere around this perimeter area and this inner margin now, and you might have little spatter cones or little fountains or new places where it pops up, and you might see anything happen from any angle at this point in time. Right? So right now the viewing is actually lava visible. If you went to the northern side of Waiakahuna, you maybe could see these lava flows over there from that direction, despite the fact that from the south it's paused. Interesting little thing there, right? So that's because of that crack over here. That's one of the first ones to develop over here in this northeast side, along that perimeter of that older, harder cap. Right? That's possibly floatier.
With each one of those flow ups from the east side, it gets a little bit adjustment to equalize the height.
Yeah, exactly.
Since we only have that, we only have that one rangefinder, so it's not really that accurate in terms of what we're trying to talk about here.
Yeah, exactly. Yeah. So I think there are adjustments exactly that are happening over there on that eastern side, right? And just like I see these pattern of cracks here in the foreground, this is an adjustment that's going to happen on this northwest side. I wouldn't be surprised to see some little ooze-outs and things like that over here as well. Or not, maybe it can bulge and bend enough without actually having to crack all the way through. We'll have to wait and see, right? But it's interesting to see this whole landscape evolve, where now, compared to this, the acreage that we have here of this hardened crust, that original central island is becoming quite small, with its margins having been really encroached upon the last few weeks here. Each of these last surges that have come and wrapped around and lapped onto it, it's kind of stuck. It's if you look at this, when I was zooming this back and forth, you can see that the island is rising a little bit too. It is bulging as well as part of that original crust, right? But it's not moving as fast as it wants to be, apparently. So it's not keeping up, and it's getting covered by lava flows coming over the top of this thing. Changing that landscape. Yeah, really fascinating to see how it's changed over time here. So if we look at the lava depth over the last week, here's the plot of that. We had a very, very brief almost pause, and then we've had this longer one going on through here that we're currently in with the lava depth down by about 10 meters, according to the USGS report, about 30 feet or so. If you look at the summit tilt for the last week, you can see that that's the pressure tilt, the ground tilt of the volcano. It's a proxy for the pressure underground in the magma reservoir and magma system. And you see that there's a very clear correlation between these two graphs, right? So we can see here at this far right end that just recently the volcano has begun to reinflate at a steep rate. And so it seems like tonight, more than likely, we'll see the lava burst back out of that vent, but it won't be until a little bit later, it seems, right? Before it reaches these levels where it'll actually burst out. But when that happens, it seems like it'll probably put out quite a show, as it has been the last few times, and flood parts of the caldera and burst out of the vent in other places and have multiple points, and really like a lava landscape. Like, what could you possibly imagine in there? And, you know, like rivers going this way or that way, or cones and fountains. Really some amazing things that could be seen. Yeah. That's the benefit of having this start-stopping pattern, this pausing pattern that's been going on, is that when it comes back, you get that extra oomph of it, and you get an extra spectacular burst. But the downside, of course, is that you have to better time your visit, because not guaranteed you're always going to see the lava there all the time, right? As I just mentioned, depending on which side you go from, you might see something different every time you come. Really a fascinating time to. Looking over the last month, here's lava depth on top. You can see that overall there's been a steady, slow rise. So you can see that the crater it's bulging upwards and filling with these larger variations within these filling and draining cycles than you've seen in the last rise in this total month, right? We've seen maybe a 10-meter rise over the last month, something like that. And you can see that that's the same order of magnitude as the variations we're seeing of the filling and draining every time. And especially recently, very closely resembling the tilt. Some variations that we saw earlier, we documented in the past. Okay, and this is important because also tied to the summit pressure is the gas emissions, right? And when the lava levels are down like they are now, you have less gas coming out, and therefore less hazard. And that's what we're trying to get at with this first part of our update here. Is the main hazard of people is still a gas on a volcano, seeing as everything is within the big pit in Kilauea caldera and Halemaʻumaʻu crater, all within Hawaiʻi Volcanoes National Park, and not threatening any. Really, the gas emissions that come out as they come out and burst. When that big burst of lava comes out, we'll have a big burst of gas as well. It'll travel and make a little fog cloud, and it might tail off at some point. But that's what we're dealing with as far as trying to anticipate the hazards. So we have a couple ways to look at that. Here is a 1-month summit SO2 at a permanent continuous station at Sandhill, which is wind dependent, right? But you see that there are times where clearly there is more gas than others, right? This is a very close site, so that's why you're not surprised to see these high values of 6 ppm or more recently 4 ppm or so. They're also doing integrated measurements, and so here's the measurements for the whole plume, the fully integrated measurement here of SO2. And they've also been up in the range of 3,000 and down in the range of a few hundred, and then recently up in the range of a couple thousand and down in the range of a few hundred, and essentially mirroring this up and down pattern of the tilt and the lava lake and the gas all going hand in hand. So that means that the VOG forecast that we have here is worst case scenario. This is coming from University of Hawaii Manoa, the VOG mapping project, VMAP. And this is the next couple of days here. Speed this up a little bit. See the effect of the mostly right now trade winds coming from the northeast and blowing the source of fog, mostly the southwest, of course, South Hawaii offshore as well. Some effects in the Kona area as well. Right, so not a whole lot of change this coming few days here. And within the park, everything is still in the green. You can see the direction of the plume blowing away from all the viewing areas are all to the north and the east, right? And the plume is blowing to the south and the west. So all the stations have been in the green all day. We can go back by a sight once again. Green all the way down, all throughout all the sites. Great if you're planning to see the park. And just to mention once again that all this information is coming from the USGS HVO daily updates and other media and reports they're putting out. So here's a one from this morning, for example, and here are some of the things I've said. Eruption is paused, all activity confined to the crater, and no indications of activity migrating elsewhere in Kīlauea. There are short-lived minor flows of active lava from the west vent and flows to the southwest and into the western lava lake. There were no significant ooze-outs along the margins of the lava lake during the past 24 hours. The decreased effusive activity corresponds with a drop in tilt of approximately 2.6 microradians, with corresponding decrease in tremor at the summit. The high point on the floor of Halemaʻumaʻu crater has dropped approximately 10 meters, 33 feet over the last 24 hours. The active lava lake is now approximately 84 meters, 276 feet deep relative to when the lava emerged on September 29th, 2021. Erupted volume is 45 million cubic meters, 59 million cubic yards of lava as measured on January 25th, about a month ago now. You can see a lot more detail in these updates, and you can see that's that main detail point of that high point dropping 10 meters over the last 24 hours there. Right, so that's the highlights there. You can certainly read more, but I bring this up because USGS has now added, in addition to making the morning Kilauea daily update, HVO is issuing a brief eruption status report around 3 p.m. Hawaiian Standard Time due to frequent pauses in eruption and the highly variable nature of the lava lake activity within Halemaʻumaʻu crater. The addition of afternoon status reports does not reflect a change in hazards. These reports are intended to give Hawaiʻi Volcanoes National Park staff and visitors an idea of likely lava activity for the coming evening. So this is a bonus update for all the visitors and park. So this is awesome, coming out 3 p.m. daily. They've started doing that this week. So the one for today, as of a couple hours ago now, Hawaiʻi volcano eruption remains fully paused at the time of this notice. The level of the lava lake has dropped significantly, and the surface is completely crusted over. I'll skip ahead a little bit. It has increased approximately 0.8 microradians, with a rapid increase in inflation occurring at 2:45 p.m. Hawaiian Standard Time today. Based on previous observations, lava will likely not be on the surface of the active lava lake until later this evening or tomorrow. Based on past activity, it would likely be at least 6 hours until the eruption restarts. So at least 6 hours, they're saying that puts it 8:45 p.m.-ish. So still a few hours to go from when we're broadcasting right now, but pretty cool little bonus bit of information put out by the USGS. So mahalo, you guys. And I'm sure that all the visitors and especially the people in the park will appreciate this extra bit of a daily update here. Sure. So if you're going to the national park to view the lava, of course, check the park website for all the current conditions and all that. But here's our park map once again at the summit, and the main viewing point in the south at Kanakakoi is down over here, right, with parking in the area of Devastation Trail or Pu'upua'i, and then walking in along the old Crater Rim Drive this way. Or over here on the north side, Kilauea Overlook or Uekahuna, or the area in between. And perhaps there are, depending on as the lava flows are coming up higher and the crater floor is getting higher, there may be some other areas along the Crater Rim Trail. If you have a whole bunch of time, you can make a whole circuit here in the evening. You might see glow from some of these other areas as well. Glow, or perhaps even bits of spatter shooting where you're looking at from and what's going on. And so right now, maybe that viewing is better from over here because you're looking. This is a viewpoint that looks at this eastern part of the crater floor, right over there, whereas this Kanakakoi side looks more so at the western and northwestern part. Kind of different areas, different points of view there. So still, here's a view from the S1 camera from USGS HVO, which is just recently restored. It was down for parts of the week earlier, so I won't show you guys a time lapse of that. But this is corresponding to what the viewing might look like right now. Right now, because the pause has been going on for a while, or very near the end of the pause, you see not a lot of red or glow or anything like that. You still see some gas coming out, but really not nearly as much over here. However, depending on the levels of pause, here's a view, an image released by the USGS of a weak flow on February 18th, so a little more than a week ago, but you can see that even during times of low activity, you may see these little rivers coming through the canyon of lava, feeding small flows on the crater floor. This is all really far away, so it really helps to have a telescope. You can see this is shot through a scope here. Nice bit of media from the USGS there. We will instead then turn to this KW camera time-lapse, which is viewed from the west. This is not exactly a point of view that the tourists and visitors can get to, whereas Kilauea is, that viewpoint is somewhere around in here, somewhere right in here, and it's looking at this area over here, more or less, right? So you can see by the fluctuations right here in this part of the lava lake what you might be visibly seeing from Kilauea over here. Whereas this back part over here might be more of what's visible, and maybe you can't quite see that much. I haven't quite mapped it out exactly, but it might be something like this that you can see over here from this Kahuna side from the north. Look at this again. Keep your eye on this back part, and you see activity over here in the back. That tells you when activity is visible from the north. And then a little see a little better out here. You can see that there are times where you might just see some spattering. You might hear the noises, or other times you might see bigger flows over here on the eastern side, whereas you have a typical, as we've recently documented, activity happening over here in this active lava lake area as usual. So that's been the recent viewing over the past week. We do have a couple of clips highlighted, sent in and shared by John Tarson of Epic Lava once again. Keep it short. But here is a view of that burst out, right? And so there's a few things to look at here. Here's our main west vent. There's a new river coming out of the south side over here. You can see that's flowing down kind of out of sight and out of view of out of frame here. Big bursts of gas throwing lava up, building these cones from multiple spots here on this west vent complex. Here in the foreground, here I'm going to put it back to the beginning once again. Here in the foreground, you can see the edge of this active lava lake pond, which is over here in the bottom right, and the lava from this river on the south side is wrapping around and pouring over, cascading over that lip here into the foreground. And if we scroll it over here to the right, we have that west vent pond bubbling over here, going through that tunnel and emerging in a standing wave here in the foreground. Oh, here's another burst of lava from another part of that west vent complex. So there's that standing wave as it emerges from that little bit of lava tunnel, and getting to be a lava tube. When lava level is really quite full, it is kind of like a lava tube, but when it's a little bit lower, it seems like it flows through more like the original spillway pathway. This is the side of the west vent here. This is that big new chunk of lava that's bursting out, and here once again that cascade of lava coming over the edge into that main active lake area. So this is a few of the highlights submitted by John Tarson, Mahalo. And in the daytime, a view of that active lake area bursting and overflow of that lake area, sending a big river of lava out into another part of the crater. So really cool stuff is visible, of course. This is all shot using a telescope, but we really appreciate that. Mahalo to John Tarson and Epic Lava for sharing that. We have images from the USGS as well, slightly different angles, but we like to show you guys the stuff that's shot from the publicly accessible areas where you might be able to reach yourself as well. But to add to the story, here's a little highlights of the USGS clips. Right? So this is back a couple weeks ago now, when we didn't have anything crusted over in that pathway area. We can see big chunks of crust getting rafted around that rapids area. That's pretty narrow, where most of that lava is going through that skinny outlet. And then once it comes out, it starts spreading out and crusting over and cooling, and you can still see bursts of gas from the edges of the perimeter of these things. And here, this is a view from the shot in real time of that area, right, overflowing with lava, spilling over with that active complex. And we're going to zoom into it here, you can really see this whirlpool swirling action going on over here, spattering over here on this western side, and you really have like an overflow zone going around this way from the main pathway, which is actually over here on the right side of the zone going off this way. So really cool stuff there. Really cool media from USGS. That's our media for the week here. And our time-lapse of the week will be this V1 camera, that same view as well. But we're going to start off with that first curiosity that it shows, and it zoomed way into this active pond area to look at this zone of where this little bridge is going to form. Let me play it for you guys here. And you can see that there's all this pulsing and the lava levels falling and rising, and when it rises it kind of floods everything. You can see other parts in the perimeter rising and falling as well, but keep your eye on this gap right over here and how every time the lava level drops back down, a gap is a little bit closer. And you can see a lot of this perimeter over here also crusting over, and it drops back down again, and not quite touching here on the 16th, but it comes up on the 17th. And now, when it comes back down, now we have an archway formed right over. And that archway fills. You can see lava going through the middle of that canyon, spilling over this overflow zone once again, that when lava level drops back down again, it doesn't use that pathway. It stays in this little circular pit, right? And then as it comes up and down, it's spilling over this overflow this way and spilling over back to the west in this direction, or to the southwest in that direction. But the actual outlet, this hole, is way down and underneath the surface level over here, right? And that's how come when lava levels are down lower, it's still feeding lava through that canyon, a little bit out of sight. Pretty cool to see, as lava levels drop down, to see that glowing in there. But get a good view of it here to freeze on it for you guys, yeah, something like that. Maybe. That was a one. All right, we'll move on from there. That's the closed-in view of our curiosity of the week there, that little archway that's forming. Time there. Play it from here, perhaps. See it still unconnected. Zoom it way in. There it is. Dropping down, coming up. Spattering on the edges, overflowing. Really cool stuff. Curiosity. All right. We'll move on to show you guys just one more time that view in a wider angle, because we now actually have originally this west vent complex in here. So you can see the bursts of spatter that form little bits of new cones, like one right over there. You form a new little peak within that complex. It gets a little bit quiet. Later on, we see another burst, and it forms another cone over here. All meanwhile, while this archway is forming down here in this bottom left of it. A combination of seeing that development of the spillway and new high spots forming in a cone. Right over here. Pull that one back, guys. More time in that upper right corner right there. Here it goes. You can see it's like a drip castle at the beach or something like that. Make one peak on top of another peak and another peak, and you see that they're growing and growing and growing and changing shape. And meanwhile, the canyon is evolving, the spillway. See lava bulging up and pushing the crater floor from below in some spots. See lava wrapping around the south side and spilling over that berm over here. On this part over here. There it is. So a really fantastic view. Our time lapse of the week. And so to see what's happening at the V1 camera now, we'll switch over to the live USGS page. We'll reload it here and just show you guys it's no glow, nothing visible. That archway looks dark at this moment. I'm still await that it'll change later tonight. Keep your eyes on the cameras throughout the next coming days. For that. All right, we're going to wrap it up here with looking at our geophysics. Here's our GPS. This is a summit GPS. You can see that we're following the same trend as before. Pretty slight extension here, not as quick as we were doing last year, during that eruption last year. So it's very modest, very minor. And on Pu'u'o, the long-term trend really hasn't changed. You see maybe some minor variations if I zoom way in here at the bottom right. Maybe there's been some little bit of change, but we've had little fluctuations before that have been inconsequential. So really, we have to wait and see what's going on there. And if we're going to look slightly deeper into that, we can go to the Pu'u'o tilt and see that it's still showing deflation. Nothing going on. It's all just business as usual. So nothing to worry about with the GPS there. As USGS says, and we magma. Earthquake-wise on Kilauea, here we are at the right side, where it's been pretty constant. What it seemed like it might have been a slight little dip was just a temporary couple-day thing. You can see that this is earthquakes per week over the last year. So we've had peaks during intrusion preceding eruption, and more recently adjustments underneath the summit that were more interesting than right now. It's actually pretty quiet and fairly boring. So that's by week. If we scroll down here to our 1 month plot, earthquakes per day now. So you do have variations where a few days of slightly less and a few days of slightly more, and maybe 1 day of less and 1 day more. And you can see that we've had a couple of days of slightly less here, but it's really not been that much of a change, and it's really not that eventful, and there's not a lot to talk about here, so we won't spend a whole lot of time. Here's where they are in the last week in the same areas as usual. No surprises there. Over the last month, look at these patterns here, looking over time, right? Maybe slightly less, but it's just all within an overall normal scatter of natural data. Okay, so that's the earthquake plots from USGS. Here's our most recent map. Looks like our most recent earthquake's at 2.5 up here near the surface, Mauna Loa. We've had some big earthquakes in the last week, Deep Pahala as well. A whole bunch of threes, I believe, right? Following that 3 that we announced last week, a couple of threes last week. But to jump right into Mauna Loa, we'll look at the Mauna Loa plot for earthquakes for the last year, earthquakes per week once again. You can see that we're over here on the right side, and actually during one of these low phases. And it was looking a little more interesting for a little while there, but really we're back to not a lot of adjustment going on. And look at the GPS cross cutter of Mauna Loa, it's also similarly not showing a whole lot of trend. It's pretty flat, really. It's not showing any slight rise. It's not showing any steep rise. It's not showing any steep drop. It's really kind of within this zone of scatter here. It's not doing a whole lot that's meaningful to interpret. So there's some on Mauna Loa once again. We'll close this book on Mauna Loa and just mention one last thing for update today. Volcano Watch today is about volcanism in eastern Turkey possibly being related to the Bronze Age floods. This is a piece by Don Swanson, so this will be posted if you guys want to check that out. Connections of eastern Turkey and we'll call them historical eruptions, that are cultural, biblical eruptions. Like that. That's Volcano Watch today. And with that, Dane, we can see any last questions and say some thank yous and not take anyone's time any longer here.
Right. Trying to do a little bit shorter update this week, just with everything kind of going on in the Ukraine and all that jazz, kind of distracting. So we're just going to go into it. We appreciate everybody that did show up today. We rely on viewers like you to really, get those the algorithm for YouTube working in our favor instead of against us. We don't have an advertising budget, so a like, subscribe, a share, those really go a long way to support us. If you want to support us further, we do take monetary donations on hawaiitracker.com/support. We also do take super chats on YouTube. We like to thank Kaleo's Bar and Grill in Pahoa for being a longtime sponsor of this program. They have 2 locations now, one in Pahoa, one in Orchidland. The Pahoa location's a little hit or miss on the opening days, but the Orchidland one's open, I think 7 days a week now. Indoor, outdoor dining, takeout options. They got a local twist on some more traditional dishes and really good options. So definitely check out Kaleo's, and we appreciate them for being such a long-time sponsor. We don't have that many questions today. If anybody, I'll keep an eye on chat if anybody wants to throw a last-minute one in there. But the last one I had was about I don't think I have. I think I answered them.
Yeah, see some interesting comments, right? Nathan saying the pond is transforming into a cone. Yeah, it's interesting to see that transformation going on there. It's pretty cool. And
Two Pineapples was wondering about the size of that new cone. Like, how wide is that hole, ballpark? And I was going through some of the last HVO updates just to find a point of comparison. Couldn't find something really good to compare it against.
They were saying that the width of that pond was something like, I want to say 30 yards, something like that.
When you remember when that was? Because that's been getting wider, right?
Yeah, it has been. Yeah. But it's probably a few yards wider. It's probably not like 10 yards wider, I would say.
Okay.
But yeah, it's I think each individual little peak is actually not that big, right? But I think that the base of them is all merging together, and that bottom part is getting to be pretty broad, and it's become kind of elongated in the direction of that rift that lines up that pond, and those little spatter cones on the north side of the main west vent, and then now the ones on the south side, it kind of all line up in a big line. So I think it's kind of just as they all spatter out in each of these bursts, like there's building that base up, and when you have these smaller gas vents that crack through anywhere it can crack, and they start building up these smaller little piles on top of that. They're really, really interesting. Like it's we've seen too that when the burst comes back through, it'll come and just flow out of those cracks and holes and just wipe everything out and start all over from scratch. So they're all really transient features too. So really cool to look at those as well.
Richard does have a good question here. Just dropped it about the turnover and what we've seen historically in the previous lava lakes. Have we seen that crustal overturning to the point like where this cap might become compromised and maybe some of it flip over?
So I don't know that we've had something like the cap necessarily. We've had reports of islands, right? Like these smaller chunks of rock that have been in there that have tilted and sunk in, and like a ship kind of thing over a course of days. But that was all within a larger liquid at the surface area. So what we have right now, as far as what we're seeing I don't believe so. But I also think that we're looking at a part of this evolution of that long-term summit activity that we don't have prior to the early days of Kilauea's Western record, at least. Right, so it's hard to know how that came about, how we came to have like a semi-solid plug of lava that was like a piston that would rise and fall with the pressure of the volcano, and lava would erupt through it and build features above it, and then that actual plug would deform and rise through the liquid above it to form these islands and cracks, and they could rise and fall at different points and become detached and float around and tip over and sink in. And that was all that era of lava lake from when the first observers like Jagger and Frank Perret first arrived, more than 100 years ago now. But so they kind of missed what happened before that to get to that point in time. And that's a good question, right?
Yeah.
And the answer is
the islands definitely come to mind of them, the overturning that we were looking at in some of the previous. Yeah, the islands. I remember we were talking about that in the early stages of the 2021 eruption. That when the island formed, like, oh, could that thing actually, overturn somehow, or something along those lines? But
yeah, and it seems like it was like too attached to the rest of the stuff in hindsight now.
Right.
But yeah, I mean, it's now as the larger area that's at least, even if it is semi-solid, very recent lava flow, maybe that makes it more mobile if it's gooey in the inside enough. But that middle part could start tipping, maybe. I don't know, but it stayed relatively. I can't imagine it tipping all the way over as broad and wide as it actually is. I mean, I more see it cracking on one side and tipping and kind of doing a wiggle,
right?
Cracking,
right.
And maybe if it's easier on one side, it does become inclined at some point, maybe, if that's how it works out, but not necessarily.
Right, that cap's decently thick at this point in time, and the bottom of it has to be malleable or some kind of semi-molten state. So it has some ability to, maneuver as needed. So I don't see it really splitting in half type of thing. But that was an interesting thing just to talk about, because with those islands that happen.
Yeah, throw one more wrench in there. Like one thing we did see also in a lot of those historical reports is collapse of the walls of the crater onto the lake. and that disturbing the lake surface or doing something to the lake surface as well.
Right.
So we haven't had a whole lot of that, and maybe everything's stable enough, but I mean, you might get one at some point. You might have a little collapse of the wall of the crater somewhere, and it might do something interesting.
Get a decent shaker earthquake and just set something, let it go.
Yeah, because imagine if the whole ground starts to bulge and deform like that surface of the lake is starting to do, and it starts to spread beyond just that, now you can start wiggling some of those parts, and something's unstable still, and then it can fall over. And maybe nothing big enough, right? But if something hits a crust and the crust isn't very thick, could you then induce some kind of outbreak? I don't know. That'd be interesting. Interesting kind of fringe border case. Right.
Those lava lakes can get kind of agitated surprisingly easy with the amount of introductory force and then the reaction that you get out of it type of thing. So I could see that, some rocks come down and cause something a little bit bigger to go down in there.
Yeah, but for sure, I mean, I think the outlook is that we're seeing that, more deformation of that surface of the lake, and we should expect to see more breakouts possibly anywhere around there.
Right.
And so, that's exciting for us. We'll see what we see.
Wherever it starts to pinch and maybe needs that adjustments, the next place to be watching maybe. All right. Well, I think that does it for us today. Ended a little early. I will pass it back to you.
Yeah, sounds good. Yeah, we may go a little shorter and slightly different format next week as well, but we'll let you guys know how that goes. Any change. So we'll be back at the same time next week and update what's going on in Kilauea, Mauna Loa, if warranted. Mahalo you guys for all your support. If you haven't liked, do that now. Share, subscribe if you haven't yet. You probably are subscribed already if you're watching us to the very end by now. Mahalo for sticking with us, and mahalo for all your support. And until next week, aloha everyone for Hawaii Tracker. He's Dane DuPont. I'm Philip Ong. Aloha.